Welcome to another C program beginner tutorial. In today's presentation, I'll first explain you what a compiler is and how C code is actually executed. The task of a compiler is to read the entire code that you wrote and transform it in machine code. Machine code is represented in 0 and 1. There's a wide range of compilers that you can choose of depending on your operating system that you have installed on your computer. In this table, I've only listed the most popular compilers. At first, the GNU compiler was only made for C on Linux. After the time, GCC started supporting other programming languages. Therefore, it is called GNU Compiler Collection, and we'll be using GNU as a compiler. On macOS, Xcode is really popular, and on Windows Visual Studios. Notice for programming in embedded systems come mostly with their compiler and IDE. Something important to know before starting programming is actually to understand how a code is executed internally. So let's start. Imagine you press a button on your keyboard or click with your mouse on an icon on your laptop. Ever wondered how your computer understands what you've clicked or pressed on? It is quite simple. The central processing unit, also known as CPU, receives this input. Here on the image, you can see the von Neumann architecture. It has been developed in 1945. Most of the computers in use today are based on the basic principle of the von Neumann architecture. In total, this architecture has 5 components: the input-output that controls data input and output, the control unit, which interprets the instructions of a program and controls the sequences of instructions. The arithmetic unit performs arithmetic operations and logical operations. And last but not least, the register that stores programs and data. In order for those to communicate, we have the bus system. Nowadays, there is a wide range of architecture, such as the Intel Core i5, published in 2010, the AMD Ryzen architecture, published in 2017, and last but not least, after 10 years of development, the ARM version 9, published in 2021. Once the CPU has received the input, the information is transferred to the hard disk. The hard disk is the secondary storage and contains all executable files. Behind every single shortcut on your computer is an executable file that makes the program run. On a hard disk, you can find, for example, PowerPoint, Word, Chrome, Explorer, and so on. All the instructions are transferred to the RAM, the random access memory. This memory is temporary. This means when you turn down your computer, the memory wipes everything on it, whereas the hard disk deletes nothing. In RAM, we have now all our instructions. The CPU is working sequentially. That means it reads the instructions from the top to the bottom and executes them. It is also possible that an instruction is linked to another. For example, instruction 3 refers to instruction 1. Here, the instructions are no longer executed sequentially. This CPU is responsible for the execution. It executes millions of instructions in seconds. Why is a direct communication between the CPU and the hard disk not possible? The access to the RAM is a lot more faster compared to the hard disk. There will be a huge delay in time if the hard disk and the CPU would interact directly. Lastly, the output of the CPU is displayed on your monitor. In summary, we can say programs are safe on the secondary storage, but when executed, they are on the primary storage. Once finished, the RAM's storage is being cleared.
The input output, right? The hardware is always input output. The first thing you do to know is that you have a programming language like C. You write your code because it's easier for a human being to read it and understand it, but that the compiler, the GNU compiler that you said previously in the previous stage, we then transform that code, that C code that you've written, in machine code. The machine code means that a code that the central processing unit can read. And you have different type of architecture, for example, for Neumann, Intel, or AMD Ryzen, or ARM architectures. So the compiler will transform that instruction that you gave to the machine, to the CPU, in the way that if the CPU is from Intel, you will transform it so the CPU can read it correctly, your instructions. And then if you say, for example, I want to open the Word data and save something inside, then the CPU would then go to the hard disk and collect the data into the RAM. And then from there, you can start doing what you want and send what you have written or in your program to your monitor. Is the output, what someone can see. So the input is your keyboard, and you give in the input the C language code, you write your program, and the compiler translate it in a way that the machine, the central processing unit, can read. And when that is read, and then you send it to the hard disk collect the data from the hard disk, put it in the RAM, so it's easier to read. And we see it in more detail later. But the most important information is to know how this works. If you don't understand right from now, you will not be able to program properly embedded systems like the computer. Or embedded system function like you see here, the central processor, you need the input, output, the registry, the compiler. If you don't understand all those words, you will never be able to be a great developer, embedded system developer. Thank you.